Good morning, everyone. I am Andrew. I will be the digital FAE supporting customers in the Indonesia region. So if you need any support on the TI's embedded processing products, you can reach out to me for support. Yeah. Okay. Today, I would like to go a little bit more in depth about the aforementioned M0 and the C2000 MCUs that my manager Eddie has presented in the previous topic. Yeah. So let's get straight into it. Okay. So for the agenda, so first we will have a little bit of a talk over the TI's ARM Cortex M0 portfolio and on how it is scalable, very scalable for your development. And also, I noticed that you had some questions about the IDE and ecosystem. I will be going over in depth all over about the how you can develop on our ecosystem as well. And next, I will go into the application-specific MCUs, namely our C2000 real-time microcontrollers and its relative ecosystem as well. Okay, so the general philosophy for the M0 is cost optimization. So we aim to provide you with the best price-to-performance ratio when it comes to our low-cost MCU, right? And it comes in very small packages as well, and we aim to have like a very general purpose when it comes to the M0. So if you have a look at the, let's say the car here, the M0 pretty much fits into any industry that you place it in. So medical, building automation, appliances, car access, body lighting, powertrain, onboard charger. Yeah, so you just need to pick a device optimized for your solution. Also, I will elaborate more on what I think is the strongest suit for the M0 here, which is the pin-to-pin portfolio. Yep, so as mentioned before, so here we can, this is the roadmap that Eddie has mentioned before. Yeah, so you can see. Yep, so you might notice that the M0 has a lot of letters behind its name, so C, H, L, G, but for now, let's just understand that the M0 is the ARM Cortex M0, and M33 is ARM Cortex M33. Yep. So here, so if the M0G is our best computing lineup of MCUs, M0L, which is the lowest power, so start up to 32 megahertz of computing power, and M0H, which is our first 5 volts MCUs. And here, M0C, which is our lowest cost, which is the 16 cents MCU that we have mentioned before. Right, so here you can see that it has a very wide variety of pin packages ranging from 8 pins to 100 pins, from 8 kilobytes of flash all the way up to 512 kilobytes of flash. We will come up with more flash options down the line, but this is what we have in production so far. Yeah. So now, for now, let's if you pick a device for your purposes. And as let's say if you pick an M0C or you pick the 20-pin packages, right? If you pick an M0C and you think that it is too little flash for your use case, you can always scale up like to an M0G 64 kilobytes with the same code, with almost zero changes to your code when you are developing on this MCU. You just need to change at one click of a button using our ecosystem, and I will show you that later. Yeah. Okay, I just want to highlight our latest release this last quarter, which is our 5 volts lineup, so which is the M0H. So this one, it's on TI.com. You can order the pre-release part. It starts at around 50 cents only. Yeah, it has a 32 megahertz ARM Cortex M0 at 32 or 64 kilobytes of flash and 8 kilobytes of RAM. Yep, starting at 50 cents. If you want samples, we can ship you the samples as well. Yep, it has UART with LIN, 12-bit ADC with 27 channels. Yep, and it is a direct pin-to-pin replacement to the Renesas RL78. Yeah, on the QRF 32 and 44 pin footprint. Yep. And also, if you are replacing an existing Renesas MCU, we have the migration guide from our RL78 to MSP-M0. Yeah. Okay, and here, which is another very exciting release as of now. Yep. So this is our newest flagship performance M0. So this one, it has a 32 megahertz as well, MCU with up to 64 kilobytes of flash. And oh wait, sorry, I'm on the wrong slide. Yeah, so this one, it actually has a 80 megahertz G series MCU. So this is the half a megabytes of flash and 100 pin that we have seen before. Yep. So it has a 9 general purpose or advanced timer with up to 28 PWM channels. Yep. So this is very cost effective as well, and it also has a very wide voltage range of 1.62 volts to 3.6 volts. Yep. You can have a closer look here at the peripherals on the screen. Yeah. Okay, as mentioned before, we have a lot of drop-in replacement from our competitors as well. Yeah, so, but one case that I really like is this. This one here, the STM8S003. So this is actually an 8-bit MCU, but our 32-bit MSP is also a drop-in replacement for this one. And the best part of the MSP S003 is that if you have a look at the STM8S to MSPS migration tool, it is actually just a single, you can actually copy the code from the IDE that STM uses to CCS, and you change one header file, and your code will work. It's only one line of code, yeah. Okay, so for MSP-M0, like I said before, we have a very extensive analog subsystem, such as I/O expander, power sequence voltage supervisor, ADC to communications interface, system startup, and configurations controller. And also, the applications that we aim for this one, well, to put it plainly, I think it pretty much fits in everywhere, because I've had medical applications using MSP-M0 as well. So from appliances, building automations, medical, yeah, if it fits inside of the environment temperature, this M0 can fit in anywhere that you can think of. Yeah. Okay, so now let's get to the development ecosystem, right? Because if you have the performance and you have but you don't have the correct ecosystem to support the development, then I don't really see the point of developing your chip. Yeah. So first, for the IDE, we have our very own Code Composer Studio. This is free. But also, if you want to use a third-party IDE such as Q or IAR, you can also do that as well. But here, recently, we have just launched this for very simple applications. We have the MSP Zero Code Studio, which is a graphical development environment. It's exactly like the name suggests. You don't have to code on the MSP-M0. It is a block programming interface. I will show you the UI later, but it's just connecting blocks together to create a program, and the program will write the code for you. Yep. So here for debugger, we have our very own XDS 110, which is TI's JTAG. Yeah. And if for third-party options, we also support the Sega J-Link as well. And for programming tools, we use Uniflash. And production programmer, we have the MSP Gang for mass production programmer. Yeah. Okay, and all of this is compiled into this here, which is called the Launchpad, which is our evaluation module. So if you find a device that you really like in this past presentation, we can ship you a free sample which supports everything that I have mentioned here before completely for free. Yeah. Yep. So now let's have a look at the MSP Zero Code Studio, and then I will show you some of the software associated with the MSP M0 as well. So here, so what is MSP Zero Code Studio? So it is a drag and drop visual interface. So you select from a very wide array of peripherals, and then you configure those blocks, and then you map it together, and it will write the program for you. So here you can see that this is a very simple application. This is on button press. It will read from an ADC channel, and then it will trigger a delay, and then it will write something to the serial terminal. Yeah. So the tool will actually generate the executable code file, and the code will build behind the scene, and then it will automatically flash into the chip as well. And I think one of the best things about this tool is that it is also available online. Yeah, you can use this without downloading the tools, and it will automatically flash into the MSP M0. Yep. So here, when you are developing on our CCS, we actually have a tool called sysconfig. So it's short for system configuration. It is a very simple application to configure your onboard peripherals. So if you want to add in a GPIO, LED, timer, you can just click the press of a button, and then, here. So here you can see that, so if you want to add a GPIO, you can just click plus, and then you select the channels that you want to configure. There's no configuring from the code. So that leaves the development mainly on you developing your algorithm on the M0 or any of TI's MCUs. Yeah. Yep. So the main strength of sysconfig is it is very easy to use. You can add hardware or software peripherals with one click of a button, and also it will provide you with real-time feedback. So if you have like two pins that are overlapping each other, it will automatically flag like, look, these two pins are not compatible with each other. You can do this to fix it. Oh, yeah. And it will show you warnings like as you move along with your development. So the development is very hassle-free. So yeah. Okay, and then actually, it's just not a simple UI, right? So because the way that sysconfig works is that if you click and add a peripheral, the CCS actually generates the code for you. The configuration code actually shows up as TI-MSP dlconfig.c and config.h. So the configuration, it's done by programming for you in the background. Yeah. Okay, so here, this is a look at our CCS. This is the latest version of the Code Composer Studio. Yep. So if you are using our old CCS, you might see that it is a little bit different. So with the newest version, the version 20, we actually moved to a Visual Studio Code like user interface. Yep. So this one, we actually have a very wide variety of features. So here we have the source code editor, which is pretty standard. And then here, you can also do your project management on the file side. It's pretty much look the same as Visual Code Studio. But what I really like about this is here, you can have a very wide variety of features. So here you can see this is a memory browser. You can see the memory change in real time. This is a variable watcher. It will, like, as the code runs, you can watch your variables change in real time. So let's say if you have an array that is updated as the program moves along, the variables inside of this buffer or the array, if you add it to watch expression, it will change in real time, and you can actually graph the values inside of that array in real time as well. Yep. So you can a little bit use it in place of a oscilloscope if you want to, like, sample an PWM using an ADC. But the refresh rate, it's not going to be nearly as good as an oscilloscope, right? Yeah. And here you can. This is the memory management. So this one you can actually watch the flash and RAM usage. Yeah. So you can pretty much have a very complete development experience with the CCS that we have. Yeah. Okay. Before we move to C2000, do you want to ask any questions about the M0?
Yes, thank you. My question is, in the MSP Zero Code Studio, you said that it's a graphical interface.
Yes.
But can we still add our own code to it to make it more versatile or maybe fit to our application needs?
Yes. Here you can see that if you use the CCS Zero Code Studio, you can click on this icon here, and you can see all of the generated files from the Zero Code Studio, including the main. The main.c file. Yeah.
Oh, okay.
Yeah, so you can see the algorithm generated by Zero Code Studio, and you can somewhat implement it into CCS. But the main roadblock is that the sysconfig is, you have to do a little bit of configuration, but that's it. It will generate everything from scratch for you. Yeah.
Okay, thank you.
Thank you. Is the MSPM0 already an SOC type of chip, or do we still need external component like the oscillator, capacitor, and other things to make it work on our PCBs? Thank you.
Can you repeat the question? Do you mean like the soldering onto the board?
For example, if we use other chips like Atomega, we need put the oscillator on our PCB, right?
Yeah.
It does not include it. But what about the MSP M0? Do we still need to add external capacitor, external oscillator to make it works, or it already included?
So external component for the MCU, right? Yeah, we still need some capacitors on MCU, mainly on the power lines. Yeah. Then JTAG is external also.
What about the oscillator? Do we
oscillator? We can have an on-chip. We have an on-chip oscillator for I think it's about 3% accuracy. But if you want to do real-time clock, like 20 ppm accuracy, then you need a crystal. But if you're okay with 2%, 3% accuracy, we can use the on-chip oscillator.
Thank you.
Thank you.
Okay. Thank you for your questions. Now I will move to our next in our FZU lineup, which is the C2000 real-time application microcontroller. Yep. So here, so compared to the MSPM0, for our C2000 is actually more focused on some of the more application-specific that you need like a signal chain for, right? So it's for wind power, appliances, motor control, power supply. Yeah. So that's what we aim to do with our C2000 microcontrollers. Yep. So for the C2000 real-time microcontrollers, for the signal chain, for the sensing, we have very high accuracy, very accurate sensing. So it's 12 to 16-bit ADCs and up to 24 channels. It has a full analog comparators with built-in ADC. Yeah. So for processing, we have very high performance C28 core, also coming soon is C29 core as well, including the lockstep features that Eddie has mentioned before. Yep. And for control, we have very highly flexible, high resolution PWMs. So for some of our chips, it has available up to around 32 outputs and channels. Yeah. And for communications interface, we have CAN, CAN-FD, LIN, UART, SPI, I2C. Very complete set of communications interface, including EtherCAT, if you require that one as well. Yeah. So here, as you might know, the C2000 is a very long legacy of MCUs inside of TI. And I am very excited to share with you our latest additions to the C2000 lineup that we have today, right? So because here, you can see it's actually over 25 years of expertise in real-time control systems. We have very extensive software libraries because this C2000 has been around for a very long time. So the software libraries are very tested. Yes, so we have very extensive reference design, functional safety compliant devices. Yeah, and then we are also leading the innovation in CLB, which is this configurable logic block for peripheral communications, FSI. Yeah, and also we are compliant with a lot of safety regulations as well. Yep. Yep. So here is the roadmap that we have for the C2000 devices. Yep. So right now we have 3 in production, which is the F28001X line. We have just released our latest F28P5 products, and also the P6 as well. So the difference between the P5 and P6 is that the P5 has 150 to 200 megahertz with FPU and trigonometry math unit. It also has control law accelerator, and it is also the first C2000 with a neural processing unit, which is used to compile and process with our, which is Edge AI. I will show you that how you can develop your AI model a little bit later with our Edge AI Studio. Yeah, it has a 12-bit ADC, hardware security, and configurable logic block. Yeah, so this is the main selling point for the P55. But here for the P65, it is pretty much a P55 on steroids, if you are if you want to put it that way. Yeah, it has 2 CPUs, each has 200 megahertz. Yeah, hardware security, and it also has built-in EtherCAT. Yeah, so it's very good for factory and motor control applications. Yeah, and it also has a 16-bit ADC. Yeah. So coming soon we have the F29, so it has 200 megahertz F29. Yeah, but here I want to highlight this little guy here, which is the F28E products. So actually, this is our lowest cost C2000, starting at just under 50 cents. Yes, so real-time control is now 50 cents per chip. Yep. So just a little bit of a highlight into the P55. So this is what we have in the market right now, which is the P550X. So like I said before, it's 150 megahertz CPU with control law accelerator with a lot of trigonometry math unit, and yeah. But what I really want to highlight is that the P55 and the C2000 generally has a lower clock speed than the other MCUs, but that is because we have all of these peripherals surrounding the chip that is used to taking the load off of the MCUs, and we can leave the MCU to do the very CPU intensive task, right? So 150, we actually ran a benchmark for the C2000 with the 150 megahertz. Is actually more efficient than a 300 megahertz ARM Cortex M04 just because of the surrounding peripherals taking the load off of the CPU and leaving it to do the calculations. Yeah. Okay. Yep. So here you can see that the P55 has the AI engine for the to compile, right? So this is generally the development flow for the Edge AI. So first you collect the data, and then you train the model in our Model Composer or Edge AI Studio. The software is completely free. You just need, the only roadblock is you need to collect the data yourself. Yep, and then you compile the model, you deploy the model, and then you integrate the model into our CCS. So the development is pretty straightforward. And also, on our Model Composer Edge AI Studio on TI.com, we actually have example data for you to select from. So this one is actually for a voltage arc detection. Yeah. So in the power supply, there's a voltage arc. This is the data for that we have collected and compiled into an AI model that you can try and test it out today yourself to test out the accuracy for that model. Yeah. Okay. Yep. So for the ecosystem, it is actually quite straightforward. So here, the application, we have three main application for the C2000. First is the industrial drives, automotive, and then motor control. But I just, in terms of like software, right? So the development toolchain that we use will be the CCS or the CCS Cloud. The CCS Cloud is just an online version of the CCS. Yeah. So because the CCS Cloud is you can actually use the IDE online. So for some of the development that I've or training for the customers that I have done, some of them, when I come to the office, they don't actually have CCS installed. So I just do the entire lab online. It works by uploading your projects onto the cloud and then compile it running from the cloud. But I gotta say it's quite slow, so you're better off installing the IDE onto your PC. Yep. So here for the software, yeah, as I said before, so CCS Cloud, sysconfig, which is the configuration software that we have mentioned before. So these two we use to configure all of our embedded processing products. Yep. And also, we have Resource Explorer, which contains all of the documentation for the peripherals for every single one of our embedded processing products. So if you want to read more about a certain feature that we have, it is all available on this Resource Explorer, which you can see for yourself on dev.ti.com, or it is built into the CCS. So you can actually have a view when you boot on CCS. Yeah. And for the software development kits, we have the base C2000ware and the digital power SDK for power supply applications, and then the motor control SDK for the motor control applications. Yeah, for EVMs, we have launch pads, like same as the MSP M0 that we have said before. If you say you kind of like the P55, we can send you a free sample for the launch pads. We also have the control cards and also reference design kits. Yeah, so we actually have a reference design for all of the applications that you might be interested in, so we can ship you a board for you to evaluate yourself. Yeah, we have a very extensive support team at TI for the C2000 products. Yeah. Okay, so so this is how you would I would recommend to evaluate the C2000. So first we have the entry level. If you are new to the MCU ecosystem, we can use some low-cost development options, which suggest using the launch pads to run some example programs, right? Yeah. So again, these launch pads we can ship you for completely free. Just talk to us. we will get you the boards and get you the support that you need to start your development as soon as possible. Yeah. Yeah, so again, these launchpads, it has an onboard debugging probe, so you don't need an external or anything. You just plug it into your PC and start coding. Yeah. Okay, so once you are getting more the advanced level, I would recommend that once you're more experienced with our C2000 MCUs, because it is a real-time microcontroller, so you need some tuning. Yeah, so once you are more familiar, you take reference from one of our reference design. So it comes with the Gerber file, the source code, everything that you need to, and the schematic as well. So basically everything that you need to start your development on the reference design. Yeah. Also, once that you are done with your development, TI also offers schematic reviews where we will review your schematics and then give you some feedback based on that schematic as well. Yeah. Okay, so how would you go about, and let's say we have presented a lot of roadmaps, right? But how would you go and select an MCU on MSP M0 or C2000? So this is where I would like to highlight, this is not a software, this is what you can find on TI.com. Yeah, so if you go, we have the MCU selection tool. So for the MSP M0 selection tool, here you can filter based on your specific needs. So you want CPU clock to be at a certain megahertz, flash memory, RAM, or some specific like CAN-FD, or LCD drivers. It is all filterable on TI.com here. Yeah, and then it can generate the comparison tables between each M0s for you to make your most educated selection for the M0. So you don't have to waste time by requesting this sample and these samples. Yeah. Yeah, and also you can, not only can you compare performance, there's also the pricing as well. Okay, and then here, and other than the M0s, you can filter products based on your specific application as well. So this is the page where if you for a cordless handheld garden tool. So this is like a just a general block diagram for some garden tools that you might find in your yard. Yeah, this is the block diagram. So here you can filter. If you click on the MCU side, it will recommend you all of the MCUs for that fits your need, and then also the surrounding peripherals, analog peripherals as well. Okay, so here, and then because one of the main roadblocks of starting a new MCU is you might see that it is a very big investment to learn that MCU. It takes a lot of time to get familiar with the ecosystem, the tool chain, the software development kits. So this is where that is a problem that at TI that we aim to solve here with our TI's MCU Academy. So here we have the MSP M0 Academy. This is the one-stop shop for the MSP M0 documentation. You can find every single information that you need on the M0 on here. And it provides in-depth explanation and documentation, training labs for key features of the MSP M0. Yeah. Here also, same thing for the MSP M0. We have the C2000 Academy. Yeah, again, it has detailed explanations for each peripherals, even for such a complex MCU such as the C2000. You can also learn this yourself, or you can reach out to me, and then I can shorten that time to maybe like an hour or 2 hour training session for you to get familiar with with what we have in terms of documentation and labs, and get you started on your development right away. Yeah. So it also has example codes as well. So not only the C28X Academy, we also have the specific reference design documentation on on CCS as well. Okay, I think that's about it for the MCU section. Is there any questions?
Hello.
Hi.
We often build a model with library Python to generate model. You mentioned about NPU, neural processing unit, right?
Yes.
We often build model with Python library. Can we run it in TI device easily?
So is the model already compiled, right? It is a
Yes, it
yes
is.
existing data set, right?
Yes.
Yes,
We compiled it with Python, and then we want to run it in the TI device. Maybe you can we run it? Okay.
Yes, you can run it on the TI device. You can reach out to me, and then we can take a look at like what that device is look like, and then we can port it to CCS. So absolutely, yeah.
So we don't need change any parameter to complete our model complete with your with TI. You understand what I mean?
Yes. Do you mean like you can? It's like plug and play into the.
Right.
Yeah. Actually, I don't think. I think some changes might be needed, but very minimal. If the format is aligns with the TI guidelines, yeah.
Oh, okay.
Yes. Very minimal. Yeah.
Thank you.
Yeah. Thank you.
All right. Thank you for your presentation. It's very insightful for me. Okay. I have a question about what if I want to build the display instrument with the MCU? So I have to make a user interface, and is that CCS can build user interface code? And how to, if I want to simulate it without the actual LCD. So is that possible for CCS do like that?
Oh, do you mean like designing a user interface with CCS?
Yeah, or do you have any tool despite CCS to make a user interface?
Is it like, do you mean like a WinForm? Like WinForm, right? That I am not sure. I don't think CCS supports the WinForm. Yeah, but if you want the LCD drivers, if you are using, let's say I have a customer that uses lvgl.io. It's an open source LCD driver that he uses for like a thermometer. Like you can click on it. Yeah. Our product line actually provides example codes based on those your needs for your development. Yeah.
Okay, so it's different tools, right?
Yes. If you want to develop the UI, you have to use a different tool. Yeah.
Okay. And one more question about the AI model.
Yes.
So I saw in your presentation there is an AI model. Yeah, and train the model, compile the model, and deploy the model. So what kind of model AI do you use? It's like generative AI or natural processing language. And so what the model that TI use for this, and what the output for the AI is like a text or can be a picture or anything else? Yeah. For the AI.
Do you mean the output for this specific model?
The output for this specific model, and what kind of model do you use for this AI?
Yeah, so for this one, like I said before, it's for a arc detection, inside of a power source unit. Like whenever the voltage arcs, they want to detect like that specific arch there. Mm-hmm. So here it's just like a yes or no. Like if you run like a input voltage through it, and then every time it arcs, the AI detects it and it flags it, like a yes or no. Yeah.
Okay.
Yeah.
So after I train the model and the model is suitable, and I have to deploy it, right?
Yes. Yeah.
Okay. I understand.
Yeah.
Thank you.
Thank you. Any more questions?
Thank you. Just a quick question, yeah. So it is interesting. Yeah, you support the NPU. Yeah. So if our devices has already deployed in the field, yeah, and then is that supporting the OTA, like over-the-air deployment? Because now the device is in the field, yeah. So how we deploy it, and is it support the OTA features for the MCU, something like that? Yeah, over-the-air. Yeah, because I think the MCU one, that is support the NPU. So how can I deploy the models once I deploy in the field, for example?
So if it's an MCU, when you want to update, you have to do the JTAG firmware update or UART firmware update.
Yeah, so it's already like, for example, it's already on the field. Yeah, so I want to update via Wi-Fi or something, yeah, or Ethernet, yeah, for example. So how to deploy? Is it like support by TI tools for that?
No, the one will be you need to develop a bootloader, a firmware update bootloader, then you can implement it. So the one is, because if it's a Bluetooth or Wi-Fi from TI, we will provide you the bootloader and the firmware update tool. But if it's an MCU, then you have to develop your own firmware updater, or you can use the on-chip bootloader. So your on-chip bootloader, then you need to have a host MCU to pump the data down to this MCU. So what we provide is the bootloader, that's all. Yeah.
Thank you. Sorry.
Yeah. Oh, just another note on that that one. The C2000 actually supports live firmware update. Like you can do a firmware update without resetting the chip. Yeah. Yeah. Thank you.